What's up, Physics 2C? Today we're going to be using physics to figure out who is to blame in a car crash. Before we dive into the physics, let's get a better understanding of the situation. We have a compact car and a truck that were coming into a flashing yellow and a red light respectively, and the car said that it came to a complete stop before accelerating, and the truck said that it slowed down before entering the intersection. However, neither of them are taking blame for the crash, so our job is to figure out who is lying so we can best figure out who deserves compensation. To begin tackling this problem, I first found the coefficient of friction by using the friction equation, and then I used that to calculate the total work done by friction in the system, and that allowed me to set that equal to kinetic energy to find the final velocity of both the car and the truck after the collision. This then, due to conservation of momentum, allowed me to find the initial velocities of the car and truck, which then allowed me to figure out who was lying in the situation. Here you can see my coefficient of friction calculations. It's a simple F equals normal force times the coefficient of friction. And the coefficient of friction, the truck was a given. It was 70% of that of the car, so I just multiplied the coefficient of friction of the car by 0.7 to get the coefficient of friction of the truck. After I found the coefficient of friction for both the car and the truck, I was then able to find the work done by friction after the cars collided simply by multiplying 4 times the force of friction multiplied by the distance the cars traveled after the collision. Due to the law of conservation of energy, I know that the work done by friction is equal to the final kinetic energy of both the car and the truck after the collision. This allowed me to figure out the final velocity of both the car and the truck right after the collision. Key fact in deducing whose fault this car crash was is understanding where the car and truck came from. And in this situation, the car was traveling only along the y-axis and the truck was only traveling along the x-axis, meaning that all the energy in the x direction has to be given by the truck and all the energy in the y direction must be given by the car. Since both the car and the truck were traveling along an axis, I know that all the momentum in the x direction is equal to the momentum of the truck, and all the momentum in the y direction is equal to the momentum of the car. So to figure out the initial velocity of the car and truck, I must first figure out how much momentum the car and truck had before the collision. After I calculated the momentum of both the car and the truck, I was able to calculate the initial velocity of both the car and the truck, and I was able to figure out who was lying. If the car came to a complete stop, it only had 13 meters to accelerate at 3 meters per second squared, meaning that it could only be traveling 8.8 meters per second at its very maximum speed if it stopped. Since the car was found to be traveling 8.16 meters per second before the collision, it cannot be proven that the car didn't come to a stop at the stoplight with the information provided. This is in contrast to the truck driver who claimed to be traveling 6.7 meters per second before the collision, was actually found to be traveling 8 meters per second before the collision. Unlike the car driver, the truck driver was not being truthful. The truck driver claimed to be traveling 6.7 meters per second before the collision, but was actually traveling 8 meters per second before the collision. In British Columbia, they require drivers, if they are on the flashing yellow side, to enter the intersection with caution. The truck driver was traveling faster than they thought they were driving, meaning that they were not driving with caution, meaning that this collision is the truck driver's fault. To calculate whether the collision was elastic or inelastic, I compared the total kinetic energy before the collision and the total kinetic energy after the collision. The total kinetic energy after the collision was found to be 74% of the kinetic energy before the collision, meaning that it was not a completely elastic collision. This means that some of the energy was lost to deforming the car or truck, or into sound, or even heat.